So if you're watching this lecture, you're probably needing a little help on that last system that we had on our worksheet. And hopefully, if you were successful in the first four on that practice worksheet, where we were taking the real life situations and creating the systems from them, you were at least able to get this far along on this particular one. And again, that's probably not a bad practice to get into there. First, identifying what the variables are, what they're representing, and I really do think that helps in what you are creating for the system. And then it'll help you organize the data that you have and to put it into the right places. So my hope is that we got at least this far. But the problem is now what we have in place for elimination doesn't seem to work. Substitution doesn't seem to work either. Because not only do we not have any variables that are by themselves or have a coefficient of 1 is really what we should be saying, but they also we don't have any coefficients that are opposite or equal. So the elimination isn't really as much of an option. But in reality it is, because we can we can adjust this system so we can get back to elimination pretty easily, actually. And what you want to do in that particular case, when you have this situation here, which is substitution really isn't the best option, nor is elimination as we know it, you want to create what you want, right? We want to create the system that does allow for elimination, which is to say we want to create the system that has opposite or equal coefficients. And to do that, it's very simple. You can multiply either one or both of the equations by some number or numbers to create equal or opposite coefficients. So let's take a look at what we have. I'm looking at this one here, and neither the x nor the y have the same coefficients. But I'm going to look at, just for no particular reason, I'm going to look at the x variables. I'm going to try to get the x variables the same. They're not 4 and 6, unless something happened in the world of math overnight that I'm not aware of. They're not the same. But I'm going to look at this and say, okay, well, if I take this entire equation, this entire kind of the super distributive, and that was awful, so let me just try that again. There you go. I'm going to multiply everything in this by 3. And I'm going to go down to the second one and multiply everything by 2. Right? These numbers don't need to be the same. Right? They don't need to be the same numbers. We're multiplying everything, all 3 parts of the equation by that number in each case. Because if we do that, it's kind of like the super distributive property. We're going to say this one is going to become 12x plus 15y equals 39. The next one down, the bottom one, is going to be 12x plus 6y is equal to 30. There's no way around this. We're going to have bigger numbers to deal with, right? But so long as we multiply the entire equation by the same number, the solution, if it exists, will remain the same. We won't affect the solution. So now that we've done this, we've adjusted the system that we had and said, okay, now we're looking at this and saying, our x coefficients are the same. Once we've gotten this, now we get to just follow the steps that we know and say they're the same. We've got equal coefficients, so we're going to subtract these. And 12x minus 12x is going to be 0x, or just 0. 15y minus 6y is going to be 9y. And 9 minus 30, or 39 minus 30, is going to be 9. Meaning y, or the cost of a sunflower, is $1. Now we take that value of y and plug it in anywhere. We've got 4 options. I would recommend to take whatever you have for your variable and plug it back into one of the original ones myself. Just in case you did make a math error, you could, in this step here, you could go back to the original. So 6x plus 3 times 1 equals 15. So that's going to be 6x equals 12. X is going to equal 12 divided by 6, or 2. So roses are $2. Sunflowers are $1. So if you don't have the system that you want to use elimination, create it by multiplying one or both of the equations by some number to create that which you want, which is either opposite or equal coefficients. Doesn't matter which variable. I could have gotten rid of y, could have multiplied the top one by 3 again and multiplied the bottom one by 5. That would have worked as well, and we would have gotten to the same answers. Right? So get some practice on these from the worksheet, and then please let me know if you have any questions. Hope this helped.